Okay, I thought I would do a video on this problem because near the end of this problem, it gets a little complicated and I had some questions about it. I thought I'd just do a video for all of you. All right, so on this problem, all right, it's asking you to take this graph and answer these questions. So initially it comes across as not too bad. All right, this is called the floor function. So as you can see, for any integer from 0, including 0, up to 1, not including 1, the floor function gives you the greatest integer less than that number, okay? So like if you put in a half, if you were at a half, okay, you would go to the integer less than a half, which would be 0, and that's why it's got that right there. And then if you were at like 0.5 and you wanted to know what the value of the function was there, okay, this function, I'm going to call it f, and you did that, it would give you the integer less than or equal to that, okay? So if you're at 1.2, then you would drop down and give the integer that's less than 1.2, okay? But the greatest integer you can find that's less than that. And then if you get all the way to the other end, so say you're at 2.0, okay? When you're at 2, the function gives you the integer that the greatest integer less than or equal to this number. So your answer should be 2. Okay, so that's just kind of getting a feel for that. That's called the floor function or the greatest integer function. The greatest integer less than or equal to your input. All right, so you shouldn't have much trouble on these initial problems. So this one's asking you to do the limit of the floor function as x approaches -2 from the left. Okay, so you think about -2, here it is, approaching it from the left, okay? And as you approach -2 from the left, you're down there at -3. So here, let me go back to the original problem to do several of these without the snip. I'll come back to the snip in a minute. So as you're approaching -2 from the left, you can see as you come close to -2 from the left, you're down here at -3. So you would say -3, okay? All right, and then it's going to ask you, okay, well, what about if you approach -2 from the right? And when you look at that, you know, here's -2. When you approach it from the right, you're going to get -2. Okay. Check your answer, okay? Now, the reason that works when you think about it is if you're approaching -2 from the right, that means you're doing things like -1.5. And -1.5, the greatest integer that's less than or equal to that would be -2. So that's why you answered -2, right? And then it comes over here and it says, okay, what about if you're approaching 3 from the left? So if you're approaching 3 from the left, you're up at 2. So there you should put 2 in. Okay. And then if you're approaching 3 from the right, you go back to the picture, you can see that when you approach 3 from the right, which means you're at like 3.9, 3.5, 3.2, the answers to all of those are going to be 3. The greatest integer less than or equal to those numbers. Okay. All right, and now it's asking me to compute the limit as x approaches 2.3 from the left. So I have to think about being at positive 2.3. So that would be on the right side, a little past 2. And the limit of that, as you come from either the left or the right, is actually going to be 2. Okay. And it's asking me about 2.3 coming from the right, but that's right in the middle. So we can really see that it's going to just be 2 either way. Okay, it gets harder near the end. That's where I want to talk about it some more. All right, so then it's saying, okay, so what about the limit from both sides? Well, we got the same answer on both of those. So the limit from both sides would be 2. Okay. All right, now this is where people were struggling a little bit. So now it's asking in general for an integer. If you have, x is approaching that integer from the left or that integer from the right, what is the answer going to be? Okay. So let me show you the way to think about this. It's always harder when it gets with the symbols. So you just test it. Make sure it fits what you found. So a is an integer. So what we're trying to do in general is what happens as x approaches, say, 3 from the left, and then what happens as x approaches 3 from the right. So what if a is an integer, and we're trying to figure out this right here. Okay, so earlier when we answered it, or if you want to look again, as you approach 3 from the left, you get 2. As you approach the number 3 from the left, so you're not quite 3, you're like 2.5, 2.6, 2.7. It's the greatest integer. So I'm thinking about coming from the left, looking at, say, 2.5, 2.6, 2.7. Each time the answer is going to be the greatest integer that's less than or equal to that number. So that would be 2. But when I approach 3 from the right, then I'm talking about, so here, what I should be testing is, what if I'm at 3.5? What happens when I go to 3.4? What happens when I go to 3.2? And so on, okay? And so if I'm at past 3 and I'm coming towards 3 from the right, 3.5, 3.4, 3.2, the greatest integer less than or equal to those is going to be 3. So that kind of question we answered earlier, right? So now you can look at this and think about what happened. So this is what we're calling A. So the question a student had was understanding what they're talking about when they say A. So this is what we're calling A. And we're going to use this example to figure out what should go in that box. So when X is approaching whatever number from the left, notice you got the integer that was 1 less than whatever you had. But then notice on this one, the answer was the integer that was equal to what you had. So I just do an example or two, and then I make sure that the expression I put in here is going to be matching what I saw happen. So let me go back to the problem now, my MATLAB problem. So if this were A, then this is going to be A minus 1. So I'm going to go back here, and as I approach from the left, I should get A minus 1. Okay. So I'm going to check my answer. All right. And then as I approached A from the right, so I approached 3 from the right, which means I was looking at like 3.5, 3.4, 3.2. Then I wound up getting the integer itself back. So X could be 3.5, 3.4, 3.2, but I'm approaching the integer 3 from the right. And what happened was I got 3. A. I got 3 in that case, so that should be A. All right, so that's usually how I do it when they try to get symbolic, is I use a numerical example to test that I'm thinking right. Okay, now let's look at this one. This gets a little harder. This says if A is not an integer, what's going to happen as X approaches A from the left or from the right? Okay, so let's think about the one you did earlier. Okay, I'm going to have to snip this again. Okay, so let me snip. Okay, so on this one, A is not an integer. Here, A was an integer. So these were if A is an integer. Integer. Okay, that's what you answered on these. This one is if a is not an integer. Okay, so the example for that was like the 2.3. Okay, so if you're trying to do the limit of this function as x approaches 2.3, and they ask you for the left first, from the left, then it's like I'm using this as an example, as this being the a. So think about that. If I'm approaching 2.3 from the left, that means I'm thinking about x starting out somewhere to the left of 2.3. So maybe at 2.1, and then what happens at 2.2, and so on. And what happens is I wind up getting that to be equal to 2. And then when I do the limit of the function as x approaches 2.3 and it's from the right, okay, then I'm considering my x moving. So I'm using things like 2.5, 2.4, but I'm noticing that I still get 2. Okay, so I'm noticing that I get the integer that's less than or equal to that number. In this case, less than that number. Okay, so if a is not an integer, then the limit as x approaches a from the left-hand side turns out to be the whole number part of the a, the integer part of the a. Okay, so it turns out to be 2. That would say that. So that floor function, that's the greatest integer less than or equal to a. So it should be b, should be this guy. Okay. All right, so let me go put that in. So the limit as x approaches a from the left should wind up being the greatest integer less than or equal to. So that should be the floor function. Okay, so let's check that. Okay. All right, now I've got one that says, okay, what about when you're taking that and you're doing that from the right? Okay, well, it's approaching 2.3 and I was approaching it from the right-hand side. A was not an integer and I was approaching 2.3 from the right and I got 2 again. So I'm thinking this right here. Okay, and then let's see what the next one says. Then the next one says, for what values of a does the limit exist? So you notice that on part D, we got the same thing. When a was not an integer, we wound up getting both limits from the right or from the left of a to be the floor function, okay, to be the greatest, to be this. The greatest integer function with an a in it. So it looks like to me that the limit exists when you get the same thing from the right or the left, that it exists when a is not an integer. But remember, when a was an integer, then sometimes you got one less than a and sometimes you got a. Okay, so it needs to be part B. Okay, and we'll check that. The biggest thing I can say is when you're dealing with kind of unusual problems like that one was, something a little bit different than what you're used to doing like that one was, just try putting in an example and test and make sure that what you're writing winds up matching with the symbols that you're planning to use. Okay, so this was problem number 17 from homework 5. Problem number 17 from homework 5.